Okay. Aryan, can you hear me loud and clear?
Yes.
Okay, good. Okay, so anything happening besides chemistry ammonia?
We also learn energy change,
Right. Okay.
and we just started trigonometric, like the differentiation of trigonometric functions.
Right. Shouldn't be giving you much problem.
Yeah.
All right, good. So AMAT, if there's no problem, we go to chemistry. This is what we're going to be doing for at least until mid-year, at least, yeah. So I'm sorry that physics you have to learn by yourself first. Okay. Right. So for ammonia, Haber process. Okay. Again, if we feel that one question is too easy, we'll just skip for the next one. Understand? Yeah.
I'm kind of like I don't really understand ammonia.
Very good. Why is it so? Is it because the lecture skips through, or is it?
It's because like I don't really understand like some of the stuff.
Okay. Let me try to find out what you don't understand. Yeah. Okay. Let me try to find out. So Jamboard, please.
Yeah, I'll share with you.
Sure. Do you have any notes, Aryan? Do you have any notes from your teacher? Just checking.
Yeah.
All right. So that's not helping much, is that what you're saying?
Yeah.
Okay. So let me try to explain what's going on. I don't see your Jamboard.
Yeah, I just shared.
Okay. Still waiting. Got it. Okay. Okay, so there are only one reaction in ammonia. I suppose that's the good news, and that's all we need to understand. However, the reaction is new. So kindly, this is the new thing. This is new. This is the new guy, reversible reaction. Okay. Right?
Yeah.
So please write for me or tell me what's the reaction. Just read from that thing, right?
Yeah.
Read, Aryan. Read for me. Aryan, read for me the reaction, please.
Reaction, this one.
Yes, that is the only reaction. So you have to understand. Okay, read for me.
N2 plus 3H2.
Gas, N2 gas plus 3H2, also gas. Reversible reaction with 2 NH3,
2 gas.
also
ammonia.
gas. Right. So a few things to note. First thing first, I know this is gas, gas, and gas, but they discuss something, another thing which is new. They don't discuss this in lab. We do reactions in lab, right? No, they don't. The new thing is we discuss this in serious factory. So they call it an industrial process. Industrial process simply means we're doing it in super big factories. Okay. Now, in factory, they are, even though it's very hot, but it's very high temperature, so they are actually liquefied. No. No, they're not liquefied. They will be liquefied. So later on, yeah. So they'll make it liquid so that they can separate, which is part B. Before I continue, Mike, can you hear me?
Yeah.
All right. So today we're just doing normal homework. We're focusing on either AMAT or chemistry. So no physics until mid-year. Physics you do yourself first. Okay. Okay, now back to you, Aryan. So what is this new thing? This is the reversible reaction. Now this new thing is not saying something like this. This is finish, and this is the result. That's not how it works. That is not how it works, right? No.
Or is it that NH3 can also be like decomposed to N2 plus 3H2?
Correct. So the word decompose, I suppose that's fine because it becomes two things from one. The point is he can also do the other side, the other direction, without any requirement. He can do that. He can do that automatically. Automatically. So what makes this stop is that the speed to the left is equal to the speed to the right. They are not stopping, they are balanced. Speed to the right equals to the speed to the left. That is what is going on. So it looks like the reaction stops somewhere. It looks like that. Make sense so far?
Yeah.
So one more time, the mole thingy, the mole rule thingy still works, but it is more complicated than it's more complicated. We'll see how it goes later. So now, let me ask you something. If I start with 1 mole of Na2 and 1 mole of H2, and then nothing of NH3, because in ammonia, we usually want to produce the ammonia, usually. And usually this is the raw material, the H2 and the N2. That's just how it is. So if we start with 1 mole of N2 and 1 mole of H2 and nothing of H3, what will happen, Aryan? What will happen? Do you have any idea?
No.
Right. So let me explain that. This will reduce a bit. This will reduce a bit. This will appear a bit. So far makes sense, right? So far that makes sense, right? Okay. But then it will stop. It will stop. Why? Because remember, originally this is 0 and this is sum. So the speed to the left is a lot, right? The speed to the left is a lot, and the speed to the right is almost nothing, right? Because it's 0, so actually it's 0 lah. The speed to the the speed to the right is a lot, and the speed to the left is 0. Make sense?
Yeah.
But after a while, the speed to the right reduces a bit, and the speed to the left already increases a bit. Do you know why?
Oh, is it because NH3 is gaining?
Gaining more, so you have more going to the left, simply because you have more NH3. That makes sense, right? That makes sense. However, the speed going from here to the right is also reducing at the same time. Why? Because we have less of this. We have less concentration of this. Why? Because some already convert to NH3. So we're losing speed to the right and we're gaining speed to the left, both at the same time. Make sense?
Yeah.
And if this continues, then what will happen?
Equilibrium.
We will keep losing speed to the right, and we will keep increasing speed to the left until they are the same. And so the reaction, quote unquote, stop. It's not stopping, it's just progressing in the same speed, and therefore it doesn't seem to be changing anymore. Okay, this is new, and this new thing is what you want to understand and what they will ask you. Okay.
Yeah.
So far, so good. Now, one last thing before you try to do this question number 1. They will usually take this out. That's question B. How do they take it out? They cool it. If they cool it, all the gas become liquid. Make sense?
Yeah.
In liquid, it is easier to separate. It is easier to separate. So they separate the NH3 and then they take it out. And then the NH3 becomes 0 again. It becomes 0 again. So the speed to the left becomes 0 again. However, you still have speed to the right because there is still some nitrogen and hydrogen. Does that make sense?
Yeah.
So what will happen after they take out the NH3? What will happen?
Then the speed to the right increases. No,
the speed, right, it is not as speedy as the original, but it's still there, right? It's still there, correct? Yeah. However, the speed to the left, what happened to the speed to the left?
Almost 0.
Correct, almost 0, or let's say 0. Let's say they take out everything. So again, is it now balanced? Is it now equilibrium?
No.
Correct. So again, what will happen? Answer, what will happen in this situation?
Then, like, the speed to the right decreases. while the speed to the left increases.
Oh, you're focusing on the speed. Okay, the speed is fine. Yeah, I understand what you're saying.
Oh,
So
sorry, I mean
besides saying that, then you say, the nitrogen and the hydrogen will be consumed lah.
then the
Then you
ammonia will
have more
increase.
ammonia, and then you will again balance at a new point lah, wherever that is lah. Right, and then you just do that until you're happy with the ammonia you produce, because the whole point is to produce ammonia. Why? Yeah, because you want to produce fertilizer. They don't cover that part. Okay.
Yeah.
Okay, so try to answer this as much as you can first, and then we'll go to the next question to gain more understanding. Okay. Okay. Right. So Mike, what is your question for this one? What is this? Oh yeah, I know this question. Yeah. Zoom in, please. Zoom in a bit, please, Mike. Okay, that's nice. Okay. Before we continue, Noah, can you hear me?
Yeah.
All right. So Noah, we focus on AMAT first, and then chemistry if you want to. And that's what's happening today. Is that what you want to do? Focusing on AMAT?
Yeah.
All right, sure. Try to do the hard questions. Okay, Mike, what is your question for this one?
So I'm confused.
Right. Have you prepared your Jamboard?
Wait, hold on.
Okay, next time please prepare your Jamboard. Like I don't have to remind you every time, correct?
Yeah.
Right.
Yeah.
Okay, okay, I got it. Okay, right. Again, please tell me what is it that is confusing.
So this is part A is what was the initial temperature, so I assume that T is 0.
That makes sense. That makes sense, right?
So now I have this equation, right?
You don't know how to deal with that.
Yeah, so what is it like? I can't log inverse 0.
Okay, let's talk about this. So why do we learn log? As in log to the base of e is ln, right? Why do we do that? Because ln is the inverse. You can think of inverse as reverse lah. Is the reverse of what?
Of e.
E to the power, right? E to the power.
Yeah.
So
wait, so I just theta minus 20 over 80 is equal to 1.
e to the power of 0, which is 1. Yes. You just e power both lah. Just e power both. Remember this. This is basic logarithm. And it still works here lah. Still works here. Right. So where is the? Oh, you're trying to find theta lah. Yeah, correct. You're trying to find theta. So that works. Right? That works. Oh yeah, that works. Okay, good. Yeah, remember this. Huh? Try to continue this. Any question? No answer. So
Yeah, I've got one.
Okay, show me the question.
2.
Question 2. I'm going to copy that. Okay, show me your working.
I haven't done it.
Oh, so what is your question for question 2 then?
How do I do it?
Right, so they give you the fx, no surprises there, right? Then find an expression for f prime. F prime simply dy dx, right?
Yeah.
Right, so I suppose they're just asking you to differentiate, lah, if that makes sense. Huh? So what is your problem differentiating this? Is it the second?
Yeah.
Right, so if second is your problem, I agree. You only learn what? You only learn?
Second square.
True, but you cannot differentiate second square also. You can differentiate tangent to second square, right? That one you cannot. What else do you learn? So you learn tangent, sine cosine. So if you don't know how to differentiate second, I kind of agree with you, but change it to something you can.
Okay.
Right, which is in this case cosine. Yes, so it's now going to be x over cosine pi x. So then you can apply some rules.
Okay.
Okay. Mike, he's asking you the cooling rate. Stop, Mike, stop. He's asking you the cooling rate. So what does that mean?
dt d theta.
Yeah, as weird as it is dt dt. So not t lah. So he's not interested in finding t. Maybe you need it. I'm not sure that you need it. I'm not sure with it. But yeah, I'm not sure that you will need the t. So dt d theta is something that you can differentiate. Definitely you can differentiate that. Okay, Aryan, are you okay?
Yeah.
Okay, I mean, your answer is okay. Your teacher will discuss this again, right?
Yeah.
Right. Okay, so part 2, do you have any idea why?
Is it because the boiling point of ammonia gas is higher than
That's probably true. That's probably true. Then
most of the products in the mixture,
which is hydrogen and nitrogen, right? So here I'll give you something else, something to consider. So you can actually cool it until everything is liquid. So you can cool it nitrogen, ammonia gas liquid, nitrogen liquid, hydrogen also liquid. Do you want that?
No.
Why not?
Because you want to like recycle the nitrogen and hydrogen gas.
True, but the most important thing is that you want to separate the ammonia gas, which is now ammonia liquid, from the hydrogen and nitrogen gas. You want to separate and take it out. Why?
To make fertilizers.
Correct, because that's all you want. You don't want the hydrogen and nitrogen. So it's enough to just liquefy the ammonia gas. Right? Shouldn't liquefy more, because then it will be mixed again. That's not all. Okay.
Yeah.
Right. Give it a try. Noah, so far so good.
I think so. Yeah.
Right. So Mike, are you stuck?
Yeah. So
please imagine theta as x.
Yeah, I know, but I want to differentiate this, right? But then was it?
Why are you differentiating that? Sorry, that's not what you're supposed to differentiate. I'm very confused. Right?
Yeah, no, but I need to differentiate the inside to find the differentiation of this entire thing.
Now, I mean, you are correct, lah. You are correct, but I'm not seeing any. The differentiation of ln x is 1 over x, correct? So the 1 over x will be there, you promise, right?
Yeah.
Now, the guy inside, you are giving it too much credit. Really, you're giving it too much credit. It's not difficult at all. Why? Because let's imagine the theta as x. This is x minus 20 over 80. How easy or difficult to differentiate x minus 20 over 80?
Does it not just equal to 0?
Most definitely not.
Wait,
is the minus 80 bothering you? Over 80, sorry. Is the over 80 bothering you?
Yeah.
So it goes like this. X minus 20 over 80, right? If this bothers you, why don't you, for example, split them? Maybe it'll be easier to see what's happening. Split them.
X over 80 minus.
Right, x over 80 minus 20 over 80. The differentiation of 20 over 80 is just 0 lah. That's easy, right? Doesn't matter what it is. What's the differentiation of x over 80?
X.
Okay, you're gonna stop there. 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 You're gonna stop there, please. What's the differentiation of x over 2?
X over 2.
Yeah. Oh dear. If the over 80 disturb you, separate it even further. Put it in front. Do you know what I'm saying? Nice. That's a good separation. What's the differentiation of 1 over 80?
It's 1 over 80.
Good. So will this be a good technique to separate? If it is, please practice it even in exam. Okay. The question is good though. It's just that the solution, perhaps for you, the solution is to separate. Then it will give you confidence. It will give you confidence. So Aryan, can I see the top question? Is there a question on top? Okay, fertilizers. Okay, good. That part, yeah, that it doesn't look balanced.
Yeah, I'm still balancing it.
Yeah. Wow, that's very hard to balance. That's extremely hard to wait a minute. Sorry, can I see the equation one more time? Sorry, can I see the equation one more time? It looks very.
You need to add oxygen as well.
No, my guess is you have to plus H2O. My guess. On the right hand side. No, on the right hand side. On the right hand side. I think this makes more sense. Try to balance it. Try to balance it. After this, you're going to skip part 2. Yeah? Either you know or you don't know. Right? Either you know or you don't know. So just skip part 2 if you don't know. Let your teacher teach you. Right? Okay, let's learn more. So for you, Michael, I suppose the 1 over 80, the minus 7 makes sense. And then the 1 over that also makes sense. So can you settle this? Can you settle this fraction properly? Right? Noah, are you okay so far?
I've got a differentiation question.
Yeah, show me.
This in the box.
Right. So the U prime is correct. The V prime seems correct. Yeah, the V prime seems correct. And then you're using the product rule. Looks
But,
good to me.
When I tried checking, it gives a weird value.
Okay. Could you show me? Could you show me, please? Could you show me your working, please? Show me your working, please. Show me your working. No. You're working. You're writing. Why are you? Oh no. You're fine. Let me check it. V U prime looks good. Minus U. I'm not seeing your U. Oh, wait. That's minus X minus that. Okay, right. It looks good to me, but your result is wrong. That means your result is wrong. It's minus, right? Minus X times minus pi sine pi X, right?
Yeah.
So what is X times pi sine pi X?
Positive pi X sine pi X.
Where's the X?
Oh.
Now, for checking purpose, you can just change a little bit of your typing, right? You haven't pressed AC or anything in your calculator, right? Haven't, right?
Haven't.
Right. So just add the X and see what happened, right? Do check.
When checking for this differentiation, and A and B, I get this value. It's not 1.
Yeah, because you're wrong. What your differentiation is wrong.
Of
You
the
have to
V
put in
and
the
P
X. Did you use radian?
Yeah.
Let me see your A and your B. Cool, radian. And then
0.
minus pi sine 2 pi. Oh, yeah. Because sine 2 pi is 0. So what we're trying to say is use another number, please.
4x.
No, that's also 0. You can use any number. You don't have to be 2. Try to avoid the values that give you 0. For example, now let's change it to 3. Let's see what happens. Okay. So now at this point, this will be. Why is it also 0?
Still 0.
It is true that sine pi is no, it's not true. Why is your calculator making no sense? Please change the x into 3. Yeah, just 3 times 3 like that. Change it to 1. $180. Your calculator is not acting. So now let's use 1.5. Let's just use 1.5, right? 1.5 should put. So now our x should be 1.5. If that makes some sense. Okay, let's give it a try and see what happens. Mike, are you okay?
I think so. No, I need help with part B.
Sorry, I'm still checking your work. Why is it suddenly pi minus 2 below? That part I don't get at all.
Pi minus 2.
Yeah. Why is it 1 over pi minus 2?
It's minus. It's 1 over theta minus 2.
Sorry, theta. Why is it theta minus 2?
Because what, 80 divided by 80?
Oh, you made a mistake. Please check. You made a mistake. Let's check. Please check. You made a mistake. Okay. Please check. Please check and find your mistake. Aryan, can I see your question on top? So Noah, that's done, right? That should be it. Right? You should be checking the F prime though, but yeah, other than that, it's okay. You'll be checking the F prime instead. Now the equation is different. Why is your teacher giving you all this? Never mind. This is now no longer a ammonia question, just a normal mole question. Okay, good. Mike, you found it, right? I lost your video, Noah.
I just need help with part D now.
Right. So your part C seems fine. You just read, just use the same thing, right? It's good. And then part D, compare and comment the cooling rate. So obviously you have some numbers, right? So the numbers at this, I cannot see the numbers at B currently. So
minus 7 over 30.
Right, minus 7 over 30. So the cooling rate is a negative here currently, and then the there is minus 7 over 25, is it?
Not this much. Minus 7 over 5.
Minus 7 over 5. Oh, right. So minus 7 over 5 is bigger minus than minus 7 over 30.
Yeah.
What is T again? Tell me what is T again.
T is the amount of time to pass.
T is time or T is temperature? Sorry.
Time.
Oh my goodness, this is not good, yeah? So currently dt over d theta is therefore not Celsius over minute. It's minute over Celsius. The unit, because T is minute and theta is Celsius. This, the question is very weird. Look, can you see the question one more time? Can you see the question one more time? Yes, T is minutes, correct. T is, so why is he asking you the cooling rate of T with respect to theta? It should be the other way around. That is extremely annoying. The question is annoying. So you're gonna write down this. You're gonna write down dt over d theta. The unit is first thing first. Again, it will be minute over Celsius because the t is on top. The theta is on the bottom. So it's minute over Celsius. Okay.
Over Celsius.
The t is minute, right? The theta is Celsius. This is super weird. Not your fault, not my fault. The question is weird, but we cannot write Celsius over minute. It's minute over Celsius because t on top, theta on the bottom. The question is forcing you to do it that way.
Degree Celsius.
Right? I know minute over Celsius doesn't make sense, but that's what the question is asking so far. Okay, so far so good. Now, cooling rate. Now, cooling rate is not supposed to be minute over Celsius. It is supposed to be Celsius over minute. But B and C forces you to do the other way. Now, for D, I will go back to what makes sense. So in D, I'm going to now write minus 30 over 7, right? Minus 30 over 7, write down. Minus 30 over 7 Celsius per minute, right?
7 over 3.
Minus 30 over 7 Celsius per minute. Now, this is Celsius per minute because the original answer is minute per Celsius. I just flip it, make sense? Now, versus, just compare to, now this is minus 5, right? Compared to minus 5 over 7 Celsius per minute. I think this one makes it easier to answer. So, what do you think? At 50 degree, the cooling rate is that guy. At 25 degree, at 50 degree, the cooling rate is faster. At 25 degree, cooling rate is slower.
Rate.
Right? If that makes sense to you, then feel free to comment that. When it's hotter, it's cooling down faster. When it's not so hot, it's cooling down slower. Does that make sense?
Yeah.
If that makes sense, then you should be comfortable with your answer. Okay. Yes, pay attention to the teacher on how the English should be constructed. Okay, Aryan. Looks like you have some notes. You know this or you read it from your notes?
I know this.
Good. No complaints. Still pay attention to the teacher, but no complaints. Noah, are you okay so far? Is this giving you a lot of trouble?
No.
All right, good. It looks confusing, so I'm glad that you're practicing confusing questions. I'm glad.
I've got another question though.
Please ask.
I just finished this one as well.
Sure.
How do I confirm it or write down in calculator?
Can I see the question first? Mike, don't stop yet. Mike, continue. The question is which one, Noah?
Yes.
B. Okay, let me copy that. Okay, then show me your working. Zoom out a bit, please. Zoom out a bit. Too big. No, zoom out a bit more. Zoom out a bit. Still go. Zoom out. Yeah, thank you. So, what is your question? How to convert?
How do I write it down in calculator? So
right. Wow, that seems so long, right? Yeah. So let me check this. Yeah. What you're doing is great, right? And then 5 times 2 tangent. Yeah, looks great. And then and then times 2. Okay, so what you're doing seems fine. Seems fine. So how do you check this in calculator? Now, you shouldn't have problem with sine to the power of 4. You should be able to write that down. Am I correct?
Yeah.
You should be able to write down cosine and tangent also. Just secant square is a bit of a problem, correct? So for secant square, you just write 1 over cosine square. That's the only thing you can do. But you'll work fine though. You'll work fine. So you become tangent something over cosine square something. Does that make sense?
Okay. And so sine written like this.
Sorry. Like this. You should be writing it like this. Yes, correct. Okay. This is the way to write down. There's no other way. Okay. Mike, why are we stopping? Mike.
I'm stopping at the chalkboard.
You're doing what?
Something of the example.
Something in the network.
It's just a math question.
Can you settle the network problem like once and for all? Is it possible to do that?
Huh?
Like this network problem that keeps happening, is it possible to solve it?
Oh, no, it's not. No, it's not a network problem. I'm saying it's something on the Jamboard. It's an EMF problem.
Something in the Jamboard. Sorry, it's a Jamboard problem. Sorry.
No, there's an EMF problem
In the
on the-
Jamboard. In the Jamboard. Okay. Good. Let me see that.
Because I completely forgot how to do. Yeah.
You are still uploading, right? Oh yeah. Still uploading. You cannot see it yet. That's so big. Why is it so big? Why is it very big?
No, it's just part 15 only. Question 15.
Can you screenshot the? Okay. Can you just screenshot that part? Like this is loading too long. We're wasting time.
Yeah, sure.
Aryan, how is it?
It's good, but what I don't understand from this graph, right?
Go down a bit. Show it to me. Go down. Right. Thank you.
Why don't
Shift
we just
to the left. Shift to the left. Sorry. Shift to the left. Right. Okay. You're saying?
Why don't we just use like 0 degrees Celsius instead of like using like 200 and 200?
You already answered it in the first question. What's the problem with using low temperature?
Oh.
Sorry, Mike is still loading. So you do something else. Don't wait for me. Don't wait for me. Never wait for me. No reaction. There is some reaction, but it's super slow.
Yeah.
So big yield, but super slow. Not good. Right? We wait long for the yield to happen.
Yeah.
Right. So we will prefer lower yield but faster. That's what you're answering in the first one. I'm sorry, Mike, still loading. I'm sorry. Still loading. Okay, Noah, you're being very patient. Good. Being very patient. If you have some problem, just show me your typing. Show me your typing one more time. Show me your typing one more time first. Go up. Press left arrow. Thank you. Yeah. Why is this tangents? Oh, this is the original.
Yeah.
Never mind. Sorry, never mind. What am I doing? Yeah, this is fine. Okay. Sorry, Mike. It's still loading. Sorry, still loading. Wow, this is a waste of time.
No, it's not.
Looking good, Noah. Looking good, right? 2 zeros, like it, right?
Oh,
sorry.
Okay.
Sorry. What do you say? What did you say?
Is this good or not? Just have the one.
2-0 is fine.
Okay.
2-0 is fine. 1-0 better thing. Okay. 1-0 better thing. 2-0 great. Okay, good. No problem. Good job. Aryan, are you okay?
Yeah.
Okay. Mike, is there another question first? This thing is loading and not working at all. Maybe you can let me take a picture or something. This is not working. This picture is just not working. Just not working. Let's not waste time. Let's either take a picture or do something that you want. Okay, I am. Mike, do you know how to screenshot, Mike? A small portion of your screen?
Screenshot a small, yeah.
Like the window button, the shift and the S, right? Window button, shift S, right? So, okay, I think you tried that just now.
Yeah.
This is taking a long time. Don't you have any other question?
Not really.
Okay, good. I suppose that's good. Keep doing your homework then. I'll tell you when the question appears. It's not happening. Can you copy the question? Is it possible?
Yeah.
Using your hand or something?
Y equals to x
I'm
squared
going to write
plus
down. Sorry.
Yeah.
Y equals to,
x squared plus 3 over x squared minus a.
All right. Okay, then.
Make x the subject.
And your question is?
I forgot how to properly and efficiently do it.
This is what you want, right? The x like this, correct?
Yeah. X equals
Remember, how many x do you see on the result?
1.
How many x do you see at the original question? 2. Okay. Do you see anybody with the x at the answer?
Let's see anybody with the x. Yeah, no.
No, it's alone. On the original guy, is it alone? Not alone. Clearly lah, alone, right? Third problem. Is it on the top or on the bottom on the result lah, right? Denominator or numerator, the result?
Numerator.
Numerator only, right? Numerator only. So these are the 3 criteria of the answer. Look at the original guy. The original guy, numerator and denominator.
Yeah.
So how to solve this? You solve this here first, and then here, and then here. You have 3 problems. Solve it from here, and then here, and then here. Is that enough hint? Right, you're doing it, yep, you're doing it, yep. Is the over, no, it's the over y. Why do you do over y? Well, why do you do that? Yeah, I don't understand why you do over y. You cannot handle over y. Look. Your last thing, is it solving anything? What have you solved? What have you solved? What have you solved here? In the second line, what have you solved?
The second line.
What have you solved? Have you solved any problem? There are 3 problems, right?
There's no more. It's only numerator now.
Good. Denominator done, correct? So good luck.
Yeah.
Good. The next problem, I forgot to tell you, you should solve the 2 problems first. Sorry. This is the first priority. This is second priority. You see 2 x's, right? Better solve that problem first. And you are not doing it by dividing by y. You are making your life much more difficult. You're not moving strategically. Solve the 2 problems. Make the 2 into 1. Make the 2 into 1.
Okay.
How?
Wait, 1 times x.
Oh my goodness, you're doing magic. Stop. You're doing magic. How did you do that just now?
No, it's over. Yeah, wait,
And you have same problem again, correct? You have the same problem again, the denominator problem. So bye-bye. Go back to your original second line. Original second line, please. The one that you scratch. The one that you scratch. No, the original second line, the y that you scratch. Yeah, yx squared minus ya. Yeah, we're going to go back to that. How many x squared do you see?
2.
Make them into 1. You did forget. I don't like it. You did forget. Don't like it. Aryan, any question?
Oh yeah, this one.
Shift to the left, please. Thank you. Right. So I'm assuming that the dry litmus paper is currently red because ammonia gas is alkali, right?
Yeah.
The dry is the problem. You need water.
Yeah.
Okay. Done.
Oh, that's it? I thought there was an explanation.
Yeah, if there's no water, the gas cannot dissolve and therefore it cannot react with the litmus paper.
Oh,
So Mike, you're solving the two problems into one. Good. You're now solving the alone problem. Nice. Okay, the X is almost alone. Almost alone. Almost alone. Good. With the plus minus, please. Huh? So which step do you forget?
Factorizing.
Yeah, you combine them into one side and then you factorize and you solve a problem, right? You solve a problem.
Yeah.
Okay, good.
Yeah,
That should be true.
more questions. So
good. Just continue doing. I mean, we have 3 minutes left, so just continue doing your homework.
I have. I'm starting to learn electrolysis.
Good. I want to explain electrolysis. So tell me something about electrolysis. As in, did your teacher mention anything about, this is the last topic or something like that?
Oh.
Did he say anything about the topic for mid-year?
No. Yeah, we're gonna ask him, I think.
Okay. So here's my prediction. Electrolysis you will finish in at most 2 weeks, right? Electrolysis is a kind of a long thing, so electrolysis in 2 weeks. If there is nothing else, that is usually the topic before OChem. So you will enter OChem after 2 weeks. That's my prediction. But the mid-year will not include all the OChem. He'll probably only cover some or half, right? So whenever certain things become clear, like for example, things regarding OChem or things regarding the topic for mid-year, please update me, okay? Now, I want to explain electrolysis. Electrolysis is the hardest topic to understand. No, okay, it's the hardest topic to understand. So in the remaining 2 minutes, I'll start and I'll continue on next Thursday, okay? Now, before that, Noah, any question?
No.
Right. Aryan, any question?
no.
Good. Now, Mike, electrolysis is something, there's certain things that you have to memorize or understand first.
Okay.
You're looking at the Jamboard, right? Page 3, I believe, right?
Yeah.
Now, you're supposed to have this mental image every time. You cannot memorize, don't understand this. This is very basic. If you don't understand this, it's going to be very difficult to understand what the teacher is saying, right? So first thing first, there is a battery. Okay, there's a battery. The battery can be reversed. If it is reversed, you have to adapt. So let me repeat one more time. The battery can and will be reversed, and so you have to adapt. This is supposed to be liquid or aqueous. Supposed to be liquid or aqueous, and it's supposed to contain positives and negatives. So far, so good. Now, this is supposed to be a conductor. Now, my question is, this is not a closed circuit. In physics, you learn that, hey, I need current in a closed circuit. This doesn't look like a closed circuit. How can electricity flow in such thing? How is it possible?
You heat up the electrolyte. We call it the electrolyte.
Electrolyte, yeah, correct. Electrolyte, something that we drink, electrolyte. Yeah, okay. Then what happens?
Is the electrolyte like the ionic compound, the entirety of the ionic compound?
So, for example, they will give you the simplest example, NaCl, and then it becomes liquid, right?
Yeah. So it's
when you
NaCl,
heat it up,
electrolyte.
it is Na plus and Cl minus. Again, liquid. How does this help you with electricity? How does it help?
Because there's Cl and ions moving around.
And Na plus also, by the way. So since it's moving around, this is now conducting. Is that what you're saying?
Yeah.
Now, there is a few details. So I know where you are currently. So this hits around 800 degrees. So this guy better be heat resistant. Better be. The choice material is currently carbon or graphite, right? And you learn from Sec 3 that carbon or graphite do conduct electricity very well. Okay?
Yeah.
So conducting. Now you will learn more than that, but I explained the most basic thing. Once we get the electricity conducting, the first thing you must do, your teacher will not teach you this. The first thing you must do is to imagine the flow of the electron immediately from physics. Tell me, what is the flow of electron in this circuit? How does it look?
Is the longer side of the battery the positive?
You are correct. You have to memorize that. Yes, correct. You have to memorize that physics.
Oh.
So the flow of electrons. Now, Aryan, do you have any other question? Is your homework done? Is your homework done?
I don't have another question.
Right. Okay, so any news on chemistry, by the way? The next topic, no?
I'm not really sure. I think she said she's gonna go through electrolysis.
Oh, okay. So on Thursday, for both of you, I'm going to go through electrolysis as if it's a holiday tuition. Understand?
Yeah.
Be ready to learn, even though it's a short time. Now, for you, Aryan, you can stop today first. I'm just going to explain Mike in 2 minutes, and we're just going to stop. Okay?
Oh, so I can leave?
Yes, please. See you on Thursday.
Okay.
Bye.
Yeah, see you. Bye.
So what you're doing is not wrong, Mike, but first thing first, I'm not concerned with this. This is, of course, correct, but I am concerned with this first. Let me remind you that your teacher usually does not emphasize this. The electron flow is like this. Make sense, first?
Why? Because what is the negative side?
From physics. So maybe we can say from physics, the electron will appear from the negative side and go to the positive side. That's one way to say it. I think that makes sense. Another way to say it is, in physics, you know that this is the I, so you know that the electron flow is the other way around. Yeah. Either way, you have to know where the electron flows, because it's very important in chemistry. Okay? Okay. Now you draw this thing. Now this is the third thing to pay attention to. So first thing to pay attention to is the battery. The second thing is the electron flow. Now you draw the third thing. I like your third thing. Your third thing is correct. Now let's combine information number 2 and information number 3. Okay. Information number 2 tells you that the electron is like that, and also the electron is doing that. Correct or not?
Yeah.
Therefore, look at this. The positive ion is meeting the electron. The negative ion is going to eject its electron. That's what's going to happen.
Yeah.
So Na plus will meet electron. Cl minus will eject electron. This will become Na, obviously, right? And this will become Cl, but there is no such thing as Cl, so Cl2, 2, 2. Okay?
Yeah.
Chemistry do not like minus. So use door, move it here. It is still minus 2e though. What happened is really Cl minus, the electron kena ejected. That is really what happened. But the chemistry don't like it. So move the minus 2e to the right hand side, just like math. Make sense so far?
Yeah.
2e, so 2, 2, 2. You have to do that. Plus everything. What happened? The left hand side will be 2Na plus 2Cl minus. The 2e scratches, and then this is going to be 2Na plus Cl2. So far, so good?
Yeah.
You must be able to write this. This is the final reaction. Okay. And the last thing to do is, this is a cation, correct? Remember, this is a cation, yeah. This is an anion. So wherever the cation go, it's called cathode. This is also something that your teacher may or may not ask you. But I find this to be the easiest to remember. Wherever the cation go, call it cathode. Wherever the anion go, call it anode. Yeah. You will not be mistaken at all. If your teacher teach you this, then not bad. I have finished covering the easiest electrolysis. There are still more to come. Any question?
No, don't think so.
Go to draw this schematics on your paper, please. Please, let me see you do that. Then we can call it.
Okay, just run on like Jamboard,
Fine, that's fine. No, any questions so far?
No, just confirming.
Okay.
Last question.
I want you to flip the battery, please. Yeah, just for variation. Flip the battery. I think most likely we're gonna have OChem because Aryan school is also rushing towards electrolysis. You're not gonna, yeah, you can start with NaCl, that's fine. But first thing first, after the battery, second thing is the electron flow. Right, good. Now, with the electron flow, you can tell the reaction. So what happens?
Why do you say plus heat?
I don't like your reaction. I don't like it at all.
Oh yeah, no, wait.
Focus on this. I don't
Na
care about that. On this. Focus on this. Focus on what's happening here. The Na plus meeting the electron. Focus on that. That's more important than the final reaction. Yeah, I don't want the final reaction. I do not want the final reaction. I want this half reaction and half reaction. Please.
Oh.
Na plus E, please. You'll be needing it.
Oh wait, plus E minus becomes
Na plus E minus becomes Na. Yeah, okay. That makes sense, right? Easy, right? Now Cl minus E, right? E minus becomes Cl minus, Cl minus, Cl minus, Cl minus, Cl minus, right? Becomes Cl, correct? Come on. Cl minus E minus becomes Cl. But now plus it's not. Right? Since there's no Cl, make sure it's Cl2 and 2 Cl minus. So times 2 everything. 2 there, right? The Cl, Cl2, and then the 2E. 2E. Times 2 of everything, 2E. The top one also 2E. Then you sum them up. The summing up is the easy one. Now tell me which one's the cathode and which one's the anode. No, the summing up, don't care about the summing up. That's the easiest one. Cathode, anode, which one?
cathode is
Na plus, where Na plus go, and anode is where Cl minus go. Now this is the easiest electrolysis reaction writing. There'll be harder ones. Any questions so far? My emphasis is on the electron flow. If your teacher don't do that, well, we are going to do that because that makes our life very easy. I'll see you on Thursday, right? Noah, any other question?
No.
It looks good, no? A lot of zeros. I like it. Any problem so far with differentiation?
No, it's just new.
Yeah,
one.
new forms. The one that we didn't cover in holiday tuition, correct?
I think so.
But you cover it in school. That's fine, right?
Yeah.
Now, if there's no problem, that is what we expect. We'll see you on Thursday, right?
Okay.
Any updates on chemistry? Sorry, before we go, any updates on chemistry? Like, what's the topics? What topics?
For me, after speed of reaction is organic chemistry.
So no electrolysis, correct?
No.
So organic chem will be in. Great lah. We didn't waste time, correct?
Yeah.
On Thursday, I will have to cover the topic called electrolysis, which is the pure guy have, you don't have. That's fine. You can just do your A method. If that makes sense.
Okay.
Your OChem.
Question.
Yes, please.
In electrolysis.
Sorry, you're saying? Sorry.
What if I have a math question, but you're teaching electrolysis?
Oh, I will shift from them to you. I won't be doing like holiday tuition, like, oh, everybody's the same, you know?
Okay.
So they won't be doing homework. You will be doing homework. I'll just shift, like maybe, 5 minutes term, then you 5 minutes term, right? Don't worry about it, right? Okay, see you on Thursday. Bye.